So now we're going to look at the power rule of logarithms. So let's say we have log base b of x squared. Well, we could think of that as log base b of x times x, right? But then we could split that up using our product rule. So it would become log base b of x plus log base b of x. Well, notice that you have two of the same thing, right? Here's a log base b of x, here's a log base b of x. And so that's going to equal 2 log base b of x. So what happened? Well, the exponent up here came down in front of the logarithm. And so we have a rule that says this. If you have log base b of, usually they use m and p. They used m and n. I'll use what they used. M to the nth power. Then that can be written as n. So you're bringing that exponent down in front. N times log base b of m. It's supposed to be a lowercase n. Kind of looks like a giant n, but that's what it is. So I always just think of, okay, if I have a power in the argument, I can bring that in front of the logarithm. Now, it has to be just on one base, you know. Anyway, we'll talk more about that when we get to the examples. Okay, this then is the power rule. So how many rules do we have? We have our basic rules, log base b of 1, that equals 0. We have log base b of b, that equals 1. We have log base b of b to the x, that just equals x. Now, this is kind of a big deal. We use that one a lot. We have b to the power of log base b of x equals x. That's an exponential form, so we don't always see that one as much when we're working with the logarithms, but it's still a property. And then we have our product, log base b of mn equals log base b of m plus log base b of n. And then we have our quotient, log base b of m over n, which equals log base b of m minus log base b of n. And then now we have this product one, okay? Or not product, power, the power one. Okay.